Example 3. Solve for x. 4 to the power of x plus 2 to the power of x minus 20 equals 0. So this one is by far the hardest equation that I'm going to show you today, or the hardest kind of equation. To solve it, you need to be clever. What you notice here, there are two different bases, and this is a very bad situation, because if we want to use our method saying that if a to the power of x equals a to the power of k, then it means that x equals k. If we want to use this method, we need the same base. So perhaps let us try to use the same base, and there is a possibility of transforming number 4 to 2 to the power of 2. So let us do this as the first step. 2 to the power of 2 all raised to the power of x plus 2 to the power of x, this is just copied without change, minus 20 is 0. Now I can use the law about the power of the power, a to the power of m all raised to the power of n equals a to the power of mn. So if I replace this first term using this law, I get 2 to the power of 2x plus 2 to the power of x minus 20 equals 0. Well, still this situation seems difficult because, well, of course we have the same base, but the exponents here are quite different. The first one is 2x and the second one is x. But there is one possibility here that we can use, and that possibility has to do with this power law that you already know can be written as a to the power of m all raised to the power of n. Because also if you have something like that, you end up here, as well as you ended up here in this form when you started from this initial form. So a to the power of m all to the power of n is the same as a to the power of m all to the power of n. Therefore, this one can be replaced by 2, well, let me do it here, 2 to the power of x all raised to the power of 2 plus 2 to the power of x minus 20 equals 0. Now, the good news here is that the only power that we have in this equation is 2 to the power of x now, but here it's squared in the first term, then there is just this power raised to the power of 1, and then there is a term without this power. So at this moment it's a very good idea for us to use something that we call substitution or replacement. Okay, substitution, this is the word. What we should do here is to replace this recurring term by a symbol. So let me use a symbol of a. So I will call a this 2 to the power of x recurring term, or whatever it is. Okay, so a equals 2 to the power of x. Let us name this 2 to the power of x thing by the name of a. If I do that, then the equation turns to the following form. A to the power of 2 plus a minus 20 equals 0. So this is what I get. And you see, this time you have a quadratic equation. If you want, you can solve it, you can find the value of a, and this can be done by many different ways. Well, you can use the method of factorization that you should be familiar with, or you can just go for the quadratic formula, which I'm going to use now. So if I want to solve this, I'm using the formula a equals minus this coefficient here, so it's going to be minus 1 plus or minus the square root of this coefficient here squared, so it's 1 squared, minus 4 times this coefficient, so it's minus 4 times 1, times this coefficient, which is minus 20, and all is divided by 2 times the coefficient in front of a squared, which is 2 times 1, so it's 2. Okay, so the formula used here is the following, that you may remember that if you had the quadratic equation ax squared plus bx plus c equals 0, then x was just minus b plus or minus square root of b squared minus 4ac over 2a. This is what I have just used here, but the trouble here that instead of the unknown x, I have the unknown a, and so there is some confusion about the coefficients, but let us forget about this for a moment. What I did, I just used this coefficient in front of a squared, the coefficient in front of a, and the last term minus 20. So let me express it. It's minus 1 plus or minus square root of. Now you have the positive second term, so it's 80. 4 times 20 is 80, plus 1 is 81, divided by 2. Divided by 2. So it's minus 1 plus or minus the square root of 81 is 9, divided by 2. So what I get is either minus 1 plus 9, which is 8 divided by 2 is 4, or I get minus 1 minus 9, it's minus 10 divided by 2 is minus 5. So there are two possibilities for the value of a. One of them is a equals 4, and another is a equals negative 5. So if I want to use those, I have to get back or return to our substitution. So here is the substitution, and what I need to do is to use it somehow. So what I do now is the following. I take one possible value of a and replace a here by its value. So it's 4 equals 2 to the power of x. Now I can imagine 4 to be 2 to the power of 2, which equals 2 to the power of x, and this allows me to use this basic principle that we use when solving exponential equations, and to claim or to state that x must be 2. So this is one thing, one possibility. So this used the value of a equal to 4. Now let me use the second value. So replace a by negative 5. So I get negative 5 equals 2 to the power of x. Okay. Now what you can be sure here about is the following. Whatever x you take and raise 2 to the power of x, you always get a positive answer. And therefore the right hand side has to be always positive, while the left hand side, you can see, is negative. So there is no value of x which would satisfy this equation, and therefore there is no x does not exist. Okay, x is the member of empty set here. Okay, it doesn't exist in this case. So there is the final conclusion awaiting us. We have to say what is the solution to this equation that we started with, and you can see yourself that there is only one solution, and we can state it here, that the truth set equals just let me draw it better. It equals just the set of one number, and it's the number of 2. So there is only one solution to this original exponential equation.